Welcome back, everybody. Today, we're going deep into the world of lock-free data structures
Oh, yeah.
and memory reclamation.
Yeah, this is a good one.
It's a fascinating topic, but it's also super complex. So we're going to break it down for you.
Absolutely.
So think of like a system where you've got all these threads trying to access and modify data at the same time.
Yeah.
Highly parallel systems.
It's a recipe for disaster
It is.
if you're not careful.
Yeah, and like traditional locks that we use to
Right.
keep everything kind of orderly can actually slow things down.
That's right. Yeah, they can become the bottleneck in
Yeah.
these scenarios.
Right, and that's where these lock-free data structures come in.
Exactly. Yeah, they're designed to avoid that. So you can have all these threads sort of dancing around each other
Yeah.
without stepping on each other's toes.
Okay, so we've got this intricate dance of threads happening.
Yeah.
But there's a catch, right?
Always a catch.
There's always a catch.
There's always a catch with these things.
There is.
So the big challenge here is figuring out how to safely reclaim memory when you don't have locks
Right.
to act as like the traffic cops.
Right.
Because one thread might try to like deallocate a chunk of memory
Right.
while another thread is still using it.
Right.
And then,
Yeah.
oof, data's gone mid-operation.
Yeah, big problems.
It's a nightmare waiting to happen.
Okay, so sounds like we need a hero to come save the day.
We do. We do.
And that's where this Hyaline comes in.
That's right.
Is that right?
That's exactly right. Hyaline is our hero.
Okay.
And it's this new algorithm.
Yeah.
It's described in a paper from the ACM SIGPlan conference.
Okay.
And it's generating a lot of buzz because it's aiming to solve this problem of memory reclamation in a way that's fast,
Right.
efficient, robust, and, relatively easy to use.
Wow.
That's the holy grail.
Okay, so how does it work? I mean, is it like reinventing the wheel here?
Well, it builds on an idea that we've had for a while called reference counting,
Okay.
but it does it with a twist.
Okay.
So traditional reference counting has a big overhead problem because you have to keep track of every single access
Right.
to an object.
It's like taking attendance every 5 minutes in a classroom.
It is,
Yeah.
very inefficient.
Yeah. I mean, a little excessive.
Yeah, a little excessive.
Yeah.
So Hyaline, on the other hand, only uses reference counting during the reclamation process itself.
Oh, okay.
So basically, when a thread is done with a piece of data, it just raises a flag and says, hey, I'm done with this. Anyone else need it?
So it's more like a casual check-in at the end of a library visit.
Exactly.
Rather than this constant, surveillance.
That's a good way to put it.
I like it.
Yeah.
Okay. So, but wouldn't that still create like a lot of back and forth,
Right.
between threads?
Well, that's where Hyaline gets really smart.
Okay.
It uses asynchronous tracking,
Oh.
which means that the threads don't have to constantly check in on the status of, retired objects. They only look it up once
Okay.
when they're finished with their own tasks.
Got it. Okay.
And this is really important,
Yeah.
in modern systems where you have way more threads than cores,
Right.
all vying for attention.
Right. So it's like everybody kind of chips in to keep the library tidy,
Exactly.
but without creating like a huge queue
no queue.
at the return desk.
Good.
Okay, I like it.
Yeah.
So Hyaline sounds promising, but before we crown it champion,
Right.
let's look at the competition.
Yeah.
What are the other
Right,
what
yeah.
other methods are out there?
Well, think of it as like the memory management Olympics.
Okay.
We've got a few contenders, each with their own strengths and weaknesses.
Okay.
So, we've got reference counting. That's like the veteran,
Okay.
simple but a little slow
Right.
with all that constant counting going on.
So like a marathon runner who insists on carrying a backpack full of rocks.
That's exactly right. Yeah, weighs them down.
Right.
And then you've got hazard pointers,
Okay.
which is like the safety-obsessed athlete.
Okay.
Very reliable, but slow and complex to manage.
Right.
It's like having a referee meticulously check every move in a game,
Yeah.
right?
Definitely effective, but maybe a little overkill for like
Yeah, a little
a
overkill.
friendly match.
Yeah.
What about epoch-based reclamation?
EBR.
Okay.
Speedster. Known for its raw pace,
Okay.
but it has a vulnerability.
Uh-oh.
Stalled threads. If one thread gets stuck,
Right.
the whole system can grind to a halt.
Oh, that's no good.
It's like a relay race where one runner pulls a hamstring.
Ouch. Not a pretty sight.
No.
Okay, and then there's hazard eras
Right.
and interval-based reclamation.
Yeah, those are the all-rounders.
Okay.
They offer a good balance of robustness and performance.
Oh, okay.
Kind of like the decathletes.
Right. They're not going to be
Not the absolute best
the top in every single event.
in any one area.
But they're
But they're good.
good across the board.
Across the board, yeah.
Yeah, okay.
The problem is
Yeah.
they still can't quite match Hyaline's speed or efficiency.
Okay, so it sounds like Hyaline is like a serious contender here.
It is. It is.
Potentially pushing the boundaries of what's possible.
Yeah.
But before we get too carried away,
Right.
I'm curious about the details.
Yeah.
The paper mentions these variations,
Right.
Hyaline 1,
Right.
Hyaline Aura.
Yeah.
What are these?
So these are kind of like specialized versions of Hyaline,
Okay.
tailored for specific scenarios.
Okay.
So Hyaline 1, for example,
Yeah.
uses single-width CAS operations,
Okay.
potentially making it faster,
Okay.
but less portable
Oh.
across different computer architectures.
So it's a trade-off, like choosing between a lightweight sports car and a sturdy off-road vehicle.
Exactly. And then there's Hyaline S and Hyaline 1S.
Right.
These are the robust versions designed to handle those dreaded stalled threads.
Right. Okay.
And they use this really clever mechanism called birth eras,
Okay.
which is basically a way to timestamp each object and keep track of which ones might be stuck with a stalled thread.
So it's like giving each one a birth certificate.
It is, yeah.
To keep track of its lineage.
Exactly. It's a good way to put it.
Okay.
Yeah.
Brilliant.
Yeah.
Okay, so, but what about real-world performance?
Right.
Does Hyaline actually deliver on all of these promises?
That's the million-dollar question.
Bruh.
And the paper actually goes into great detail about Hyaline's evaluation.
Okay.
They tested it across a whole range of different data structures.
Okay.
Like linked lists, hash maps, binary trees, and they compared it against all those other memory management athletes we were just talking about.
Okay. And did Hyaline take home the gold?
In many cases, yes.
Wow.
It did. It did. Particularly in those redominated workloads.
Okay.
You know, where you have lots of threads, mostly reading data rather than modifying it.
Okay.
Hyaline often outperformed EBR, which was the previous speed champion, and even rivaled the efficiency of hazard pointers, which was the safety fanatic.
Okay, I'm starting to see why there's so much buzz around this.
Yeah.
But redominated workloads, why is that so important?
Well, think about how we use software today.
Yeah.
Social media, e-commerce, streaming services, these all involve far more reading than writing.
Right.
And as these applications grow more complex and handle more users, efficient memory management becomes absolutely crucial.
So it's not just a theoretical exercise, it's addressing like a real need in the software world.
Absolutely.
Okay, but hold on. The paper also mentioned that Hyaline achieved up to a 2x performance boost in certain situations.
That's right, yeah.
What's that all about?
So that's in what we call oversubscribed scenarios.
Okay.
Where you have way more threads than processing cores, all jostling for resources.
Okay.
And Hyaline's design, particularly its asynchronous tracking, allows it to thrive in these crowded conditions, which makes it incredibly relevant for these modern multi-threaded applications.
So it's like a highly efficient air traffic control system.
It is, yeah.
You know, able to manage a sky full of planes without collisions. Impressive.
That's right.
Okay, but what about memory efficiency itself? We talked about speed, but how does Hyaline stack up when it comes to actually saving memory?
Well, this is another area where Hyaline really shines.
Okay.
The paper shows that it consistently ranks among the top performers when it comes to actually minimizing the number of unreclaimed objects.
So it's not just fast.
No, it's a responsible steward of resources.
I'm liking Hyaline more and more. But before we get too carried away, singing its praises, are there any limitations or potential downsides we should be aware of?
Well, no algorithm is perfect, and Hyaline does have a few quirks.
Okay.
One thing the paper mentions is that it relies on double-width CAS operations.
Okay.
And this might limit its portability on certain specialized systems that don't support that feature.
So it's like a high-performance engine that needs a specific type of fuel.
Exactly.
Okay.
But the paper also talks about a single-width version, Hyaline 1, which is not quite as fast, but still pretty impressive.
Okay.
So clearly the researchers wanted to provide some options for different hardware environments.
Yeah, flexibility is good.
It is.
Okay, but what about the practicalities of actually using this thing?
Right.
I mean, how difficult is it to integrate Hyaline into existing clone bases?
Well, one of Hyaline's big selling points is its transparency and ease of integration.
Okay.
So unlike some other memory reclamation methods that require major code surgery, Hyaline can often be slipped in with very minimal disruption.
So it's less like a full-blown renovation.
Exactly.
And more like adding a new appliance to your home.
That's a good way to put it.
Okay, I like that.
Yeah.
But what about those robust versions?
Right.
Hyaline S, Hyaline 1S with the birth eras tracking.
Right, those do require...
Sound a bit more complex.
A little bit more effort.
Okay.
Developers need to wrap pointer accesses with a specific function.
Right.
But it's still significantly less cumbersome than implementing some of the other robust memory management techniques out there.
Got it. So it's about choosing the right tool for the job.
Exactly.
Balancing ease of use with the level of robustness that you need.
That's right.
Okay. I think we've covered a lot of ground here. But before we move on, I want to bring it back to our listener for a moment.
Sure.
What does all this Hyaline talk really mean for them?
Yeah.
Should they be rushing out to rewrite all of their code?
Well, even if our listeners aren't directly working with lock-free data structures, I think understanding these concepts can still be really insightful.
Right.
You know, it gives you kind of a peek behind the curtain of how software manages resources and handles, you know, the complexities of concurrency.
It's like appreciating the intricate clockwork inside a beautifully crafted timepiece.
Exactly. Yeah. You don't have to be a watchmaker to appreciate it.
Right.
Right.
Okay. And for those who are working in areas like high-performance computing, operating system development, any field where concurrency is key. Hyaline could be a game changer.
Hyaline could be huge.
Okay, so should our listener be brushing up on their lock-free data structure skills?
It certainly wouldn't hurt.
Okay.
I mean, lock-free programming is becoming increasingly important these days, and Hyaline is just one example of the exciting innovations happening in this space.
So what's next for Hyaline?
Yeah.
Is it ready for prime time?
Right.
Or is there still work to be done?
Well, the research is still relatively new, but it's already generating a lot of buzz in the developer community. The paper specifically mentions potential applications in operating system kernels and high-performance servers.
So this isn't just like an academic exercise.
No, this has real-world potential.
It has real-world potential.
Absolutely.
Okay, but are those the only areas where this could
No, not at all.
make an impact?
Not at all. Think about, you know, the growing world of cloud computing. Large-scale distributed systems. Even the Internet of Things. Any system that relies on concurrent operations could potentially benefit from Hyaline's efficiency and robustness.
So it's not just about speeding up individual applications.
No, it's about
optimizing entire systems.
Entire systems, yeah.
Wow, this is starting to sound like the beginning of a memory management revolution.
It could be. It really could be.
But it needs to be thoroughly tested and refined before it becomes mainstream.
Absolutely, yeah. Further research and development will be crucial in determining its long-term impact.
So while Hyaline's showing great promise, still early days.
It is. It is.
Okay, but it's exciting to think about the possibilities.
It is. It is.
But before we get too lost in the future, there are a few more intriguing details about Hyaline itself that we need to unpack. For example, the paper mentions these slots that play a role in its operation.
That's right.
What are those all about?
So remember how we were talking about Hyaline's ability to handle a practically unlimited number of threads?
Right.
Well, the slots are part of the secret sauce that makes that possible.
Ooh, intriguing. Tell me more.
Okay, so in essence, Hyaline uses multiple retirement lists, each associated with a slot.
Okay.
And then threads can choose a slot, either randomly or based on their ID to retire objects.
So it's like having these designated drop-off zones
Exactly.
for retired objects, preventing everyone from crowding around a single bin.
Precisely. And the really clever part is that these slots aren't fixed.
Oh, okay.
It can actually change dynamically from one operation to the next, which adds another layer of flexibility.
Wow, it's like having the lanes at a toll booth adjust based on traffic flow.
It is, exactly.
I love how Hyaline seems to be all about keeping things moving smoothly.
It is.
But does the number of slots actually affect performance?
That's a great question. And the research paper actually delves into that very topic. And what they found was that even with a relatively small number of slots, Hyaline often outperforms existing methods, especially in those read-heavy scenarios that we keep talking about.
So you don't need a massive infrastructure to reap the benefits?
No, not at all.
That's encouraging.
Yeah.
Okay, but what about different data structures?
Yeah.
Does Hyaline work equally well with, say, a linked list versus a hash map?
That's one of the most impressive things about Hyaline.
Okay.
The researchers tested it with a variety of data structures, and it consistently delivered strong performance across the board.
Wow.
Linked lists, hash maps, binary trees. Hyaline handles them all with grace.
It's like the multi-talented athlete who excels at every sport.
That's right.
But we keep coming back to these read-dominated workloads.
Yeah.
Why is Hyaline so good at handling them?
Yeah.
I mean, it's got to be more than just the asynchronous tracking, right?
You're right. It is. It's a combination of factors. One key element, I think, is how Hyaline handles the workload distribution.
Okay.
So in traditional methods, when you have lots of threads that are mostly just reading data, the reclamation work can become very unevenly distributed.
Right.
And that creates bottlenecks.
Right.
But Hyaline, with its multiple slots and its dynamic assignment, ensures that there's a more balanced workload. So it prevents those bottlenecks from forming.
So it's like having all hands on deck to keep the ship tidy, even if most of the crew is just enjoying the view.
That's right.
But the paper also goes into some detail about the actual reference counting mechanism, including these add.js values.
Right.
Can you shed some light on what those are?
Absolutely.
Okay.
So remember, Hyaline uses reference counters to keep track of how many threads might still be using a retired object.
Right.
Those add.js values are basically adjustments made to these counters to ensure accuracy, even when you've got multiple threads operating concurrently.
So it's like a system of checks and balances to make sure no data gets prematurely tossed overboard.
Exactly.
Just because one thread is done with it.
That's right.
Okay, so the add.js values act as like a synchronization mechanism. Okay.
They do.
Ensuring that the reference counters always reflect the true state.
That's right.
Even in the midst of all that activity.
Yeah, it can get a little technical.
Yeah.
But the key takeaway is that they're crucial for Hyaline's safety and robustness.
Okay, so it's one of those behind-the-scenes elements that might seem complicated, but is actually essential to keeping everything running smoothly.
Exactly.
Okay, but I know no system is perfect.
Right.
Are there any situations where Hyaline might stumble?
Well, as we touched upon earlier, the reliance on those double-width CAS operations could be a limitation on some systems. But the researchers have addressed that with Hyaline 1, the single-width version. However, there is another potential challenge that they highlight in the paper, and that's the overhead associated with maintaining those birth eras. In the robust versions of Hyaline.
Right, those birth certificates for data objects.
Exactly, yeah.
It seems like keeping track of all that lineage information could get expensive.
Well, that's the trade-off.
Yeah.
Right? While birth eras make Hyaline exceptionally resilient to those stalled threads, they do add some complexity and overhead.
Okay.
So the researchers acknowledge this. And they suggest, further investigation into ways to maybe mitigate that overhead.
So it's always this balancing act between performance and robustness. Okay, but even with these limitations, Hyaline seems to be like a remarkable step forward in memory reclamation. But let's zoom out for a moment.
Okay.
We've been talking a lot about the technical nitty-gritty here. But what about the bigger picture? What are the broader implications of Hyaline?
Well, that's where things get really interesting, I think. Imagine the possibilities of applying Hyaline's core principles. Things like asynchronous tracking, balanced workload distribution, dynamic resource allocation to other resource-constrained environments.
So we're thinking beyond just memory management now.
Exactly.
Okay.
We are. Think about managing network bandwidth in a data center. Or processing power in a cloud computing platform. Or even storage resources in a distributed database.
It's like taking the traffic management lessons learned in a busy city.
And applying them to optimize the flow of goods across a whole country.
I like that analogy. That's a good one.
Yeah.
Yeah, I mean, Hyaline's success with memory reclamation suggests that these principles could be transferable to other domains. And that could lead to more efficient and adaptable systems overall.
It's like discovering a new set of architectural blueprints.
It is, yeah.
That could revolutionize the way we design complex systems.
Yeah, I think that's a good way to think about it.
Okay, but let's bring it back to our listener for a moment.
Yeah.
What's the takeaway here?
Right.
For somebody who may not be, you know, a hardcore developer, but is still fascinated by the world of technology.
Well, even if you're not writing code, I think, understanding these concepts can give you a deeper appreciation for the challenges and innovations happening behind the scenes of the technology we use every day.
Right. It's about appreciating the elegance and the ingenuity
that goes into making these systems work seamlessly.
Exactly.
Often without us even realizing it.
Yeah, it just works.
Right.
We don't think about it.
It's like understanding the intricate dance of gears and springs inside a beautifully crafted watch.
That's a good analogy, yeah.
You might not be a watchmaker.
Right.
But you can still marvel at the craftsmanship.
Exactly, yeah.
Right, and for those who are interested in diving deeper into the world of lock-free programming, Hyaline is a great example of the exciting things happening in this field.
Absolutely.
There are numerous online resources, tutorials, even open source projects where you can really explore these concepts further.
Right, it's a good place to start.
Okay, so it's not just a theoretical concept, it's real-world technology with practical applications and a growing community of enthusiasts.
That's right.
But before we wrap up our deep dive into Hyaline, I want to touch on something that we haven't really discussed yet.
Okay.
And that's the ethical implications.
Ah, yes, that's an important point to raise.
Yeah, I mean, any technology as powerful as Hyaline
it is powerful.
Deserves careful consideration in terms of its potential impact on society.
Right. You have to think about the potential consequences.
We've talked about its potential to optimize systems.
Right.
But what about the potential for, like, unintended consequences?
Well, yeah, I mean, that's always a possibility with any new technology. Right. There's always that risk of things that we didn't anticipate.
Right.
So I think it's really crucial for developers, policymakers, you know, society as a whole to really engage in thoughtful discussions about the ethical implications of these advancements.
So it's not just about building cool new things. It's about building them responsibly.
Responsibly, exactly. Yeah, we need to make sure that technologies like Hyaline are used to benefit humanity, not to exacerbate existing inequalities or create new ones.
Right. It's about making sure that that progress serves everybody.
That's right.
Not just a select few.
Well said. Well said.
Okay, I think that's a powerful message to leave our listeners with.
It is.
But before we wrap up completely, I'm curious, what are your thoughts on Hyaline's potential to inspire new innovations beyond memory management?
Yeah, I think that's what makes Hyaline so fascinating.
Yeah.
It's not just a solution to a specific problem.
Right.
It's a new way of thinking about resource management.
Right. Okay.
And I think its principles, you know, asynchronous tracking, balanced workload distribution, dynamic adaptation, could really be applied to a wide range of challenges, potentially leading to breakthroughs in fields that we haven't even considered yet.
So it's like a seed that has the potential to grow into an entire forest of innovations. I love that image.
That's a good one, yeah.
But we've covered so much ground today,
Louise.
And I want to make sure our listener has time to digest it all.
Right. We've been on quite a journey.
We have, from the intricate dance of threads to the memory management Olympics.
Right.
We've explored Hyaline in depth.
We have.
We've delved into its mechanics, its performance, its limitations, even its ethical implications.
That's right. We covered it all.
And we've barely scratched the surface of its potential impact on the future of technology.
Yeah, I think there's a lot more to come.
Okay, so to our listener, we leave you with this final thought.
Okay.
What sparks your curiosity about Hyaline?
Yeah.
What possibilities do you see? Let this deep dive be the beginning of your own exploration.
That's right. Go out there and explore.
It's amazing to think that a single algorithm should have such far-reaching implications.
It really is.
But I think what's really striking about Hyaline is its elegance.
Yeah, it is an elegant solution.
You know, it tackles a really complex problem.
Yeah, it does.
But it does so in a way that feels almost intuitive.
It does. It feels very natural.
Yeah, it's like we've been trying to force fit square pegs into round holes.
We have.
And suddenly Hyaline comes along.
Right.
And shows us a completely different way.
A new perspective.
Of approaching the problem.
Yeah, I think that's a good way to put it.
And what's remarkable is that it achieves this elegance. Right. Without sacrificing performance or robustness.
That's right. In fact, it often surpasses traditional methods in both of those areas.
Right. So it's a testament to the power of smart, thoughtful design.
Thoughtful design, yeah.
It's a reminder that sometimes the simplest solutions are the most powerful.
That's right.
But I think Hyaline's real legacy might be its potential to inspire new ways of thinking about resource management in general.
I agree. Yeah, I think that's its biggest contribution.
And that goes far beyond the world of software.
It does. It does.
We're talking about applying these principles to everything from managing traffic flow in a city to optimizing energy consumption in a smart grid.
That's right. Yeah, the possibilities are endless.
It's a vision of a future where technology works smarter, not harder.
I like that. Yeah.
But for now, Hyaline is still in its early stages.
It is. It is.
There's a lot of research and development yet to be done.
Yeah, absolutely.
We need to explore its full potential, test its limits, and ensure that it's used responsibly and ethically.
That's right. Can't forget about that.
That's a crucial point. As with any powerful technology, we need to be mindful of the potential consequences, both intended and unintended.
Absolutely, yeah. We need to think about all the angles.
We need to have open and honest conversations about the ethical implications of these advancements and ensure that they're aligned with our values as a society.
Well said.
Okay, well, that brings us to the end of our deep dive into Hyaline.
It has been a fascinating journey.
It has.
Exploring the intricacies of this remarkable algorithm.
It is remarkable.
And its potential to shape the future of technology.
We've learned about its clever approach to memory reclamation, its impressive performance, and its potential to inspire innovations far beyond its original domain.
I think that's the most exciting part.
Right.
Yeah.
And we've emphasized the importance of considering the ethical implications.
Yes, absolutely.
These advancements and using them responsibly to create a better world.
To create a better world, that's what it's all about.
Okay, so to our listener, we leave you with this final thought.
Okay, shoot.
What will you do with the knowledge you've gained today?
Good question.
How will you apply it to your own work, your own thinking, your own life?
I like that, yeah.
Let this deep dive be a catalyst for your own exploration and discovery.
That's right. Get out there.
The world of technology is full of wonders.
It is.
Waiting to be uncovered.
Absolutely.
And who knows, maybe you'll be the one to discover the next Hyaline.
Yeah, maybe you'll be the next innovator.
The next breakthrough. That changes the way we think about the world.
That's what we need.
Until next time, keep exploring.
Yeah.
Keep learning.
Keep learning.
And keep pushing the boundaries of what's possible.
Could have said it better myself.
Yeah.
Understanding these concepts can give you a deeper appreciation for the challenges and innovations happening behind the scenes of the technology we use every day.
Right. It's about appreciating the elegance and the ingenuity that goes into making these systems work seamlessly, often without us even realizing it.
Yeah, it just works.
Right.
And we don't think about it.
It's like understanding the intricate dance of gears and springs inside a beautifully crafted watch.
That's a good analogy.
You might not be a watchmaker.
Right.
But you can still marvel at the craftsmanship.
Exactly.
Right. And for those who are interested in diving deeper into the world of lock-free programming, Hyaline is a great example of the exciting things happening in this field.
Absolutely.
There are numerous online resources, tutorials, even open source projects where you can really explore these concepts further.
Right. It's a good place to start.
Okay. So it's not just a theoretical concept.
No.
It's real-world technology with practical applications and a growing community of enthusiasts.
That's right.
But before we wrap up our depth dive into Hyaline, I want to touch on something that we haven't really discussed yet.
Okay.
And that's the ethical implications.
Yes, that's an important point to raise.
Yeah. I mean, any technology, as powerful as hyaline,
it is powerful,
deserves careful consideration in terms of its potential impact on society.
Right. We have to think about the potential consequences.
We've talked about its potential to optimize systems.
Right.
But what about the potential for unintended consequences?
Yeah, I mean, that's always a possibility with any new technology. Right. There's always that risk of things that we didn't anticipate.
Right.
So I think it's really crucial for developers, policymakers, society as a whole, to really engage in thoughtful discussions about the ethical implications of these advancements.
So it's not just about building cool new things. It's about building them responsibly.
Possibly, exactly. Yeah, we need to make sure that technologies like Hyaline are used to benefit humanity. Not to exacerbate existing inequalities or create new ones.
It's about making sure that that progress serves everybody.
That's right.
Not just a select few.
Well said.
Okay. I think that's a powerful message to leave our listeners with.
It is.
But before we wrap up completely, I'm curious, what are your thoughts on Hyaline's potential to inspire new innovations beyond memory management?
Yeah, I think that's what makes Hyaline so fascinating. It's not just a solution to a specific problem. It's a new way of thinking about resource management. And I think its principles, asynchronous tracking, balanced workload distribution, dynamic adaptation, could really be applied to a wide range of challenges, potentially leading to breakthroughs in fields that we haven't even considered yet.
So it's like a seed that has the potential to grow.
It is,
into an entire forest of innovations. I love that image.
That's a good one, yeah.
But we've covered so much ground today.
We have.
And I want to make sure our listener has time to digest it all.
Right. We've been on quite a journey.
We have from the intricate dance of threads to the memory management Olympics. We've explored Hyaline in depth. We have delved into its mechanics, its performance, its limitations, even its ethical implications.
That's right. We covered it all.
And we've barely scratched the surface of its potential impact on the future of technology.
Yeah, I think there's a lot more to come.
Okay, so to our listener, we leave you with this final thought.
Okay, shoot.
What will you do with the knowledge you've gained today?
Good question.
How will you apply it to your own work, your own thinking, your own life?
I like that,
Let this deep dive.
Be a catalyst.
It can be.
For your own exploration and discovery.
That's right. Get out there.
The world of technology is full of wonders.
It is.
Waiting to be uncovered.
Absolutely.
And who knows, maybe you'll be the one to discover the next Hyaline.
Yeah, maybe you'll be the next innovator.
The next breakthrough. That changes the way we think about the world.
That's what we need.
Until next time, keep exploring. Keep learning.
Keep learning.
And keep pushing the boundaries of what's possible.
Couldn't have said it better myself.